Chapter 2 Inverse Trigonometric Functions. Class number 3. Sum number 1. Find the value of sine inverse sine 3 pi by 5. Sine of 3 pi by 5 is equal to 108 degrees, which lies in the second quadrant. However, the principal value branch of sine inverse x lies between minus pi by 2 to plus pi by 2. That is in the fourth and first quadrant. Therefore, we convert the value of sine 3 pi by 5. This is done by subtracting 3 pi by 5 from pi, while the value of sine does not change with this transformation. But sine of 2 pi by 5 is in first quadrant and lies within principal value branch. Hence, the final answer is 2 pi by 5. Find the value of cosine inverse cosine 13 pi by 6. Cos 13 pi by 6 can be written as equal to cos 2 pi plus pi by 6. This value lies in first quadrant, which is within principal value branch of cos inverse function. Remember, principal value branch of cos inverse function falls within 0, and pi, that is in the first and second quadrant. Therefore, value of cos inverse of cos 13 pi by 6 will be pi by 6. Sum 2a. Find the value of tangent inverse tangent 7 pi by 6. Principal value of tan inverse is between minus pi by 2 and plus pi by 2. That is value lies either in the fourth and first quadrant. Now tan 7 pi by 6 is equal to tan of pi plus pi by 6. 7 pi by 6 is in third quadrant, which is positive for tan. Hence, to convert the given value into a corresponding value principal value branch, we will need to select the equivalent positive value of tan, which is pi by 6. Hence, the answer to the given problem is pi by 6. Prove that 2 of sine inverse 3 by 5 is equal to tan inverse of 24 by 7. Step 1. Sine inverse of 3 by 5 is positive. Hence, this is in the first quadrant. Considering that principal value branch of sine inverse lies either in the first or fourth quadrant, and sine inverse is negative in the fourth quadrant. So, a positive value of sine inverse means it lies in the first quadrant. Tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. In step 3, we replace the value of tan theta in RHS of the equation. At the end of step 3, we see that 2 theta is equal to tan inverse 24 by 7. Replacing theta with sine inverse of 3 by 5, which was our original assumption of theta, we get at the end of step 4. 2 sine inverse 3 by 5 is equal to tan inverse of 24 by 7, and hence proved LHS equals RHS. Sum number 4. Prove that sine inverse 8 by 17 plus sine inverse 3 by 5 is equal to tan inverse of 77 by 36. Sine inverse of 8 by 17 and sine inverse of 3 by 5 lies in quadrant 1, as the principal value branch of positive sine inverse function lies in first quadrant. Hence, corresponding tan inverse will also be positive, and the tan inverse is computed in the slide. In the next step, we use the formula of tangent inverse A plus tangent inverse B to simplify the left-hand side of the problem statement. In the final step, we see LHS is finally simplified to tan inverse of 77 by 36, which is the RHS of the problem statement, and hence proved. Sum number 5. Prove that cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse of 33 by 65. Step 1 and Step 2. We take cos inverse 4 by 5 and cos inverse 12 by 13 as alpha and beta respectively. Cos of alpha will be 4 by 5. Cos of beta will be 5 by 13. Corresponding values of sine alpha and sine beta will be 3 by 5 and 5 by 13 respectively. In step 3, we apply the formula of cos alpha plus beta. From the previous steps, we already know the values of cos alpha, cos beta, sine alpha, and sine beta. In step 4, we see that cos of alpha plus beta is equal to 33 by 65, or cos inverse of 33 by 65 is equal to alpha plus beta. Our original assumption was alpha is cos inverse of 4 by 5 and beta was cos inverse of 12 by 13. Hence, we proved that left hand side equals right hand side. Prove that tan inverse of 63 by 16 is equal to sine inverse of 5 by 13 plus cos inverse of 3 by 5. Step 1. Let's take sine. Inverse of 5 by 13 is alpha. Then sine alpha is 5 by 13 and tan alpha is 5 by 12. Step 2. Similarly, let us take cos inverse of 3 by 5 as beta. Then cos beta is 3 by 5 and tan beta is 4 by 5. Step 3. Using the formula of tan alpha plus beta, we see that the value of tan alpha plus beta is 63 by 16. Step 4. Tan inverse 63 by 16 is alpha plus beta. Converting the values of alpha and beta into those which we have taken in steps 1 and 2, we prove LHS equals RHS. Prove that the tangent inverse of the square root of x is equal to 1/2 of the cosine inverse of 1 minus x divided by 1 plus x. Solution. Replace tan inverse of root x as theta. Then root of x is tan theta, or x equals tan square theta. Right-hand side of the problem statement gets converted to half of cosine inverse 1 minus tangent square theta by 1 plus tangent square theta. The term under cosine inverse is equal to cos 2 theta, and thus the RHS further simplifies too. RHS simplifies to tan inverse of root x, which is LHS, hence proved. Sum number 8. Prove the left-hand side expression provided in the problem statement is equal to pi by 4 minus half of cosine inverse x. In step 1, we will have to think about replacing x with some term which can simplify the expression under tan inverse. We will replace x by cos 2 theta. Next, we replace cos 2 theta in the LHS expression into formulas related to cos square theta and sin square theta. Sum number 8. Prove the left-hand side expression provided in the problem statement is equal to pi by 4 minus half of cosine inverse x. In step 3, we divide the numerator and denominator of the expression, reached at end of step 2, by root 2 cos theta. We see that the expression simplifies to tan inverse of 1 minus tan theta by 1 plus tan theta. Furthermore, by replacing 1 with tan pi by 4, we simplify the LHS to an expression which is of the form tan A minus B. The LHS gets simplified into tan inverse of tan pi by 4 minus theta, which is nothing but pi by 4 minus theta. Replacing theta by our original assumption in step 1, we prove LHS equals RHS. Solve the equation 2. Tan inverse cosine x is equal to tan inverse 2 cosecant x. We know that tan inverse 2x is equal to 2 times tan inverse x divided by 1 minus tan square x. Replacing x in the above term by cos square x, we get the below equation. Or 2 cosine x by sine square x is equal to 2 by sine x, or simplifying further, cot x is equal to 1, or x is equal to pi by 4. Sum number 11. Solve the equation tangent inverse of 1 minus x by 1 plus x is equal to half of tangent inverse x. Replace x with tan theta. The LHS of the given equation becomes tan inverse of 1 minus theta by 1 plus theta. The RHS of the given equation becomes half of tan inverse tan theta. Replacing 1 in the LHS of the above equation by tan pi by 4. The LHS of the equation is simplified to the form of tan A minus B, whereas the RHS is simply half of theta, as the right hand side in previous step was simplified to the form of tangent inverse tangent theta. Final answer will be x is equal to tan theta is equal to tan pi by 6, or 1 by root 3. End of chapter. Inverse trigonometric functions.